Hi, I'm Ginger. I'm going to present PoseFix, correcting 3D human poses with natural language, a joint work with Philippe, Francesca and Gregory from Instituto de Robotica e Informatica Industrial and NavLabs Europe. In this work, we're interested in linking text to human pose through the following three elements: a source pose, a target pose, and a text explaining how to correct the source pose to produce the target pose. For this purpose, we first introduced the PoseFix dataset. Then we studied two tasks, where the goal is to generate one element from the other two. Specifically, text-based pose editing, generate the target pose from the source pose and the modifying text, and then correctional text generation, generate the correctional instruction to obtain the target pose from the source pose. Our work fits several applications. Correctional text generation could be used by a fitness application to help people correct their pose and avoid pain or injury. Modifying text could be used as auxiliary input to guide pose estimation from images in difficult cases. Modifying text could also be used as instructions to modify a pose or a pose sequence in digital animation. Although there is a number of related works, PoseFix is new in its kind. It studies fine-grained egocentric semantics instead of global semantics we find for motions. It does not focus on one pose but two, studying the relationship. It uses text for control. It generates feedback in natural language without resorting to predefined sentences, and it applies on 3D body poses instead of 2D images. Let's now describe the PoseFix dataset. It is composed of pairs of 3D human body poses, extracted from AMAS. The target pose were selected so as to form a diverse set of poses. The source poses were selected based on two criteria with regard to the target pose, so as to learn about fine-grained differences. First, the two poses had to be similar enough, so that writing about the differences would not lead to a direct description of the target pose, but to an actual modifier. Second, they had to be different enough for the text not to collapse to oversimple instructions. We collected over 6,000 human written annotation on Amazon Mechanical Turk, and further adapted the automatic pipeline from PostScript to generate hundreds of thousands of automatic annotations. Once we gathered the PoseFix dataset, we designed two applications. The first one consisted in building a text-based pose editing model, such that at this time, both the source pose and the modifier text are encoded, then fused as a distribution, from which we sample a Z that will then be decoded as a 3D body pose. At train time, we also encode the initial pose and sample from the corresponding distribution to decode it as a new pose that will then be compared to the initial pose as in a regular variational encoder. To make the model condition on the fusion of the source pose and the modifier text, we force the two distributions of pose and query fusion to be aligned. As a result, the initial pose can be edited in several ways that comply with the textual instruction. For instance, the model understands well left and right to position the corresponding body parts. Note that some unmentioned characteristics of the source pose are preserved, for instance, the leg opening. Our second application consists in correctional text generation. We build on top of a regular autoregressive text generation model, which, given the first k tokens, aims to predict token k+1. How does it work? The text tokens are embedded and fed into a transformer decoder that outputs a distribution of probability over the vocabulary for each token. The model is trained with a cross-entropy loss, such that the target of each token k is the token k+1. Now, how do poses come into the picture? Poses are encoded using a shared encoder, combined in a fusing module, then injected by cross-attention in the transformer. At test time, we decode the output in a greedy fashion. We iteratively predict the text token starting from the beginning of sequence token as the word that maximizes the negative log likelihood, and so until the end of the sequence token is produced. As a result, our model generates textual instructions explaining how to modify the source pose to produce the target pose. It focuses on the main differences and is able to provide egocentric instructions. Here, lower your arms to your chest. The presented results are promising, but there is still room for improvement. For instance, the model struggled with rare poses and tend to ignore some differences or instructions. Both tasks are challenging on many aspects. Here is the take-home image for this work. PoseFix is a dataset linking a source 3D human pose with target pose and modifying instructions. It aims to help learning about fine-grained 3D pose semantics. We use the PoseFix dataset to train a text-based pose editing model and a correctional text generation model. There are still many challenges to work on. Thanks for listening. Check out the QR code below for access to the dataset.